In part one, we calculated the percent by mass of this 12.3 molar solution. And in this part, we're going to calculate the molality. So we will use some of the information that we did in part one to answer part two. But let's start off by thinking about what we need to do. We know that the molarity is the number of moles of the solute per liter of solution. And we are headed towards moles of HCl per kilogram of water. The numerator, of course, is already where we want it to be, and that is that there's 12.3 moles of HCl in our solution. The work is going to involve the denominator, and there's a couple of different conversions that we have. We're given volume, and we want to know mass. We're given solution, and we need to know just solvent, the water. So let's do the denominator. Now, the biggest problem that students have when they're doing these conversions is they want to do the dimensional analysis all together in a row. But you really need to separate out this denominator, because there's more than just dimensional analysis going on here. There's going to be some addition and subtraction that's going to be going on with this denominator. If we have a liter of solution, we know that that is 1,000 milliliters of solution. And we can use the density given in the problem to go from milliliters of solution to grams of, and I'm going to make sure we realize we are working in the solution world. And so this is 1.19 grams in a milliliter, and that gives me 1,190 grams of solution. Now I know I need to do the density conversion first and not subtract out the solute, because this is the density of the solution, and I need to be working in the solution world when I'm using this density. All right, so now we're in a mass, which we needed to be in the mass world. This is kilograms and this is just grams, but I'm going to stay with grams for just a little bit and think about how am I going to get rid of the solute. Well, if I could subtract out the grams of HCl, then I could get just the grams of water remaining. So how are we going to get the grams of HCl? Well, in the previous problem, part one of this, we determined that if you can take this moles of HCl and convert it to grams of HCl, that there are 448, and it was 0.47, I'll just call it 0.5 grams of HCl. And this is going to leave me with 741.5 grams of water. Now I can convert that grams of water to kilograms of water, 741.5 grams of water to kilograms. 1,000 grams is a kilogram, and this is at 0.7415 kilograms of water. So I can now put this up here where I need it, 0.7415 kilograms of water. And this will give for me 16.6 moles per kilogram, or 16.6 molal.